Hey everybody, thanks for joining my first week 2 instructional video, and I want to start off with pointing out a resource. So you can see that I just have the course calendar open. Look at this Python reference and let's click that, and I've already done so and opened it up. This is what you get when you click on Python reference. Okay, and some of these things we don't use very much, but some of them we use all the time. And you'll see this method, the number of rows, which finds the number of rows, and this method, which finds the number of columns. We'll talk about those a little bit later on. We use the dot select method all the time, okay? And we use the dot show method all the time, and the dot sort method. Again, this is a way to get to information in a big table and to isolate the variables or the rows that we want to look at. And then dot where, we use this all the time, again, to search and to find things. And we'll talk about what that predicate means in just a moment. Dot scatter will produce a scatter plot, and dot hist we'll use to create histograms. So this is just a great reference, and some of these are not so important and some of them are extremely important. And yes, we'll use some of these array functions, but I think this is what I wanted to show you, the table where predicates, okay? So basically when we're using where, we need to say things like are equal to, or are above or equal to, or are between, are below. These allow us to use the where method and actually find things. And then the are equal to, are contained in. So these are what we call predicates, all right? And they're only used in the dot where method, okay? And at the bottom of this list, you'll notice, right, that there's some miscellaneous functions down below it, but it's the second to the last thing. So what you can do is you can click on the Python reference and kind of scroll to the bottom and you'll find the predicates, okay? So what I'm doing for today's instruction is going through Notebook 2, which you can see is right here. Okay, so there are about 4 sections to this notebook where we're going to learn different things. We're going to learn about how to name variables and about built-in functions and a little bit about tables, okay? So let's take a look at this first section of the notebook and make sure that you initialize. So if you haven't yet, pause the video and go back and open up this notebook so that you can work along with the video. And the very first thing you should always do is, run the cells that initialize everything, right? So we're going to get the data science package in here, and we'll talk about NumPy, and these last 3 lines just make the graphics look nice. Okay. And that's what the words of caution are. Okay. So the first section just basically shows us how to use Python as a calculator. And if I just want to add 2 and 18, I do in fact get 20. Okay, and same thing, if I want to do 20 minus 2, I'm just hitting Shift Enter. I'm trying to hit Shift Enter on this cell, and I get 20 minus 2 equals 18. So just doing math, 2 times 9, 9 divided by 3. Now notice that it actually gives me a decimal answer. It says that the answer is not 3, it says 3.0. Well, basically there are certain operations where basically 3.0 is a real number, right? The computer was kind of expecting there to be some decimal places in this number. It didn't know that it was going to be an integer. So here where we did 2 times 19, it just gave me the integer 18 as an answer, but it knew that if I multiplied an integer times an integer, that the answer would be an integer. Here it's expecting some kind of fraction, some kind of decimal. Okay, so that's why it switched to 3.0. 2 plus 3 times 9, that's 18 plus 2, which is, I'm sorry, that's 27 plus 2, which is 29. Okay, here we can use parentheses. The parentheses will make the addition be done first. So this will be 5. It'll add the 2 and the 3 to get 5. So that's why the answer is 49. And then they're making the point again that 2 to the 4th is 16. And just to let you know, another type of variable. So we do have integers and we do have real numbers, but sometimes we have a text variable. And when it's text, when it's a string variable, we make sure that we put the quotation marks around it. And then these quotation marks around the output are showing us, yes, the computer thinks that that this is a string or a text variable. Okay, and let me just paste this in down here. There's a warning, do not use the caret or the up arrow looking symbol for exponents, and notice that 2 raised to the third power should equal 8. And again, if we do it correctly, if we do it with the double asterisks, then it does come out to 8. But if you use this, let me get the pen here. If you use this notation, it actually produces the answer of 1, which is not the right answer. So do not use the caret symbol, this one, for exponents. Use the double asterisks. So now we're ready for the second section, and this is just introducing the idea of variables. So in the top line, the variable name is A, and we're going to set it equal to 4. Wait, let me get in here and hit Shift Enter. And notice that if I don't have A ready to print out, it just assigns the variable. It does this. It assigns the variable A to be equal to 4. And it doesn't print it out. But if I put an A in there as the last command, then it does spit out what it thinks A is equal to. So yes, we have assigned it to be equal to 4, and there, the computer thinks it's 4. Now here's a question. What does the double equal sign mean? Like what? 4 equals A? Okay, so this is a question mark. All right, this basically is the same thing as saying 4 question mark A, right? And so the answers are going to be yes or no, correct? Yes or no, which the computer will answer with true or false. Okay, so let's do the Shift Enter thing. Let me get my cursor back and Shift Enter. And it's like, yeah, our variable A does in fact equal 4, so it says true, right? If you had a number that was wrong, like let's say we put a 5 in there, it's going to say false. So this double equal sign is a question mark. It's asking, is the variable A equal to 4? And then it will tell us true or false if that's what it's equal to. Okay, so now we're going to set B equal to 9, and you can see there that the variable B is now equal to 9. Now A times 3, this will be 12 because A is equal to 4, and you multiply it by 3. So the point they're making here is that in this line, we can use a variable instead of a number, right? A is equal to 4, so we can just do A times 3, and it's the same thing as 4 times 3. And 3 times 4 should also be 12. And now notice, right? A is 4 and B is 9, so we'll add them together and call it another variable, total. And then you see that total is in fact 13. 9 plus 4 is equal to 13. Now this is interesting. We're going to assign A to be 10. And again, let me throw in the variable A as the last command there so we see it. Okay, A is equal to 10 now. And now total is equal to 13. Wait, total hasn't changed. Total is 13. Total is 13. Why? Because this, back up here, let me get the pen, right, so that we can make sure that we're talking about the same thing, right? That this total equals A plus B. This is where total got its value. And yes, it was equal to 13. Sorry. is equal to 13. Then we assigned a new value to A, but it doesn't update total, right? Total is still equal to 13. Why? Well, we assigned it its value right up here in the circle, and nothing we've done has changed anything. Now, if we come down here, and this is the one I'm going to execute next, if I reassign total the value of A plus B, that will take the new value of A into account. So let's try it. And then when I execute the command line that just says total, it says 19. Why? Well, because it thinks A is 10 and B is 9. So A plus B is in fact equal to 19. So you've got to notice that. I want to throw this out because this happens in our various notebooks that you're working with. I get people who will show me an error, and most of the time when you get a name error, it just means that the name, this variable, hasn't been defined yet. If I start using the total variable before I've defined it, I'll end up with a name error. The computer's just going to say, I don't know what total is. You haven't told me yet what total is. And most of the time what that means is that there's some code block up above that just didn't get executed. So my suggestion for you guys when you're, when that happens is to start at the top and just shift enter your way down. Why? Because with shift enter, it will keep skipping down until, right, and here's a name error, right? It'll keep skipping down. And it will initialize everything. So what was the problem here? See, Word hasn't been defined yet. And when we use it, we get a name error. Okay. Here we define it. We said, now listen though, this is not a number. Word isn't a number. And word isn't equal to what total is equal to. Word is equal to the text, T-O-T-A-L. Okay. And to show you that, I can actually do this. Let's just print out that variable. Boom. And it's just saying, hey, the text, T-O-T-A-L, is stored in the variable word. And total is still a variable that's equal to 19. So it can get confusing, but when the variable is a text, we put quotation marks around it. Either single quotes or double quotes are usually fine. They're pretty much interchangeable. And Python is telling us, hey, I understand that word is a variable that stands for the letters T-O-T-A-L. This next section is also about variables, but let me just point out that the notebooks just love using these long names like hours underscore per underscore week. Why? Well, first of all, they like to have a name that describes what the variable does. And also spaces aren't allowed, so they'd use these underscores where they want a space. So between words, they're putting an underscore. So that's why they're using hours per week, hours per year, and so forth. So here we just have two variables, hours per week and hours per year. So 40 hours per week, obviously that's not the number of hours in a week, that's the number of work hours per week. If you have a job where you work 8 hours a day, 5 days a week, you work 40 hours. And if you work 52 weeks per year, you work just over 2,000 hours. And that's what they're doing. They're multiplying 50 times 42. And you can see that the number of work hours per year is 2,080. Okay, so then they're going to say that the minimum wage for businesses goes up by $1 an hour until 2022, and the California hourly minimum wage was $15 an hour. So they're like, well, how many dollars do you earn in a week if you, right? And you find that out by multiplying hours per week times the minimum wage. And that'll give us your weekly wages if you work 40 hours. Except, hey, wait, You see this name error? Remember what I said earlier in the video? What happened? I did not initialize this, so it didn't know what the variable was. But if I do that and then execute both of those code blocks simultaneously, we can see now weekly wages is equal to $600. Sorry, I covered up the 600 there, but that's what it did. Okay, so now we want to know yearly wages. Oh, wow. So notice that we don't have a variable hours per year. Oh, wait, we do. It's up here. Sorry. So it has been initialized. And we do know the California hourly minimum wage. So then yearly wages, if you work those 2,080 hours, you would earn $31,200. Okay. And then these code blocks here, these two code blocks are just showing in number version what we did up here with variables. Okay. The point here is pretty much just to take a look at these variable names and realize that you can use something like hours underscore per underscore year. You can use that as a variable name. Okay. And a lot of times it does make sense to create a variable name that does tell us what it does, what the variable is, and that way it's just easier to remember, easier to find, and easier to work with. Now I'd like to shift gears slightly. So now we're going to talk about functions and call expressions. Okay, what does this mean? Well, functions are certain built-in functions in Python like max or absolute or min. You can see that one down here. So they're functions and they do exactly what they say they do. So maximum, it's going to find the maximum of 15, and then this, which is 54, and 50. So what's the maximum of those? I'm guessing that the answer is 54. And notice that we can do this operation, this mathematical operation, inside the function. That's kind of cool. Absolute value of 5, well, excuse me, of -5 is going to be +5. The absolute value of -2, right? 1 minus 3 is -2. The absolute value is -2. So these are functions that exist in Python, and they work just like you think. You know, it's the name and then the parentheses, and then we put inside the parentheses what we want the function to act on. So here you see we have a day temperature and a night temperature, and then we want to know the absolute difference between the two. Well, you can see 52 and 47, the difference should be 5, and you notice that they actually take the smaller one minus the larger one. So this is actually going to be 47 minus 52, which is -5. But then they're going to take the absolute value of it, so we get +5. What's the minimum of 14 and 15? 14. And then if I round the number 123 point blah, 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 I just get 123. And they're making this point about how to use help. And you can execute that if you want. This is usually not the easiest way to get help. Usually the easiest way to get help is to come over here to the Python reference page. This is a great place to get help. Round, notice that it gives me the decimal place too, and here it will round to the second decimal place. This is a way inside these parentheses to have 3 and 10/11ths. This is going to be just slightly less than 4. 1/3, as you would expect, is 0.33333, repeating. And then this is another way to round this in digits equals. So you can tell it which decimal place you want to round to, or you can use this in digits. I've never seen this before. So I don't use that very often. As a matter of fact, we don't use round very often, but it exists. And those are how we use these built-in functions for Python. Okay, so final section, let's talk about tables. Okay, so tables, why do we want to talk about them? Well, that's how we store a data set. We store a data set in a table. And what do I mean by a data set? Well, let's take a look at cones. Oh, so there's 3 columns, which means there are 3 variables. The variables are flavor, color, and price. Okay, and then you see that each row is a different menu item. All right, and we see the price for all the different items. Okay, great. Now notice it isn't that long a table, but what does this show 3? So I am going to emphasize this. Show is one of those methods that we do need to learn that is very important. So sorry that the arrow isn't exactly at show, but make a note of show, and show 3 does what? It just shows 3 rows of the table. And show 4 does what? It shows 4 rows of the table. And then this one's fun. Oh, they're going to do it. This one's fun. What does dot show with the parentheses but nothing inside the parentheses do? That's the code for show all. If I do show but I don't specify a number, it's going to show me the whole thing. Now I do want to warn you, if there's 2,000 rows in the table, it is going to show all 2,000 rows. I mean, this this can turn into a mess. So again, that's why we have show. It defaults to showing 10. You know, if you want to choose another number like 5, it's going to show that many. Okay, and here's another important one, guys. Okay, the select method. We use this all the time. And think, based on the name, what you think the method select ought to do. Cones.select, and then inside they have flavor. And it does what you expect. It only selects the columns that you name. And we name the flavor column, so we get just the flavor column. I'll scroll up so we can see most of the table above. And the color's gone, the price is gone, but we have flavor. Now notice, look, this is select, and it said, hey, I not only want to see the flavor, I want to see the price. Boom. There we are. It's just finding a subset of the table based on the 2 columns that I select. I just give the column names for the columns I want inside, and notice that they're inside quotes, right? So I put them in quotation marks, and then I get it. Cones.select flavor and price. I can also do cones drop color. Notice that drop. Now, do we use it? Yes. Is it of vital importance like show and select? Not quite, because we usually use select to get what we want, but I can, if I want to, just tell it, hey, get rid of the color column, and it will do so. And going back, just reminding ourselves of what the whole table looks like. And they name this variable cones without price, and what do? They drop the price column. And then what does cones without price look like? It looks like the table right above it, but with no price column. Okay. Now, this is one of the most helpful methods. All right. So again, along with dot sort and dot show, dot show and dot select, I want you to consider the dot where method. Okay. Cones where flavor, and that one we recognized, but chocolate. Okay. So basically this is saying, I want you to select only the rows in the cones table where flavor is equal to chocolate. And it does. Let's just scroll up just a little bit so we can see, right? There are 3 chocolates. There's a chocolate here, and a chocolate here, and a chocolate here. So there should be 3 rows in the table because those are the places where flavor equals chocolate. Okay? Now, cones sort. And you heard me say this one, but I stopped because I realized we hadn't gotten here. Sort is very important. Why? Well, if you say sort based on price, it's going to sort ascending, right? It puts the smallest value at the top, it puts the largest value at the bottom, and then sorts. Okay. Well, sometimes we aren't interested in the lowest price, although I have to admit, if I'm buying ice cream, I might like to know what the lowest price was. But if we need to know, if we want to descend in the opposite order, if we want to sort in the opposite order, we can use this command, this optional command, descending equals true. And all it does is it puts the highest price at the top and the lowest price at the bottom, and it sorts that way, okay? Um, and I'll just hit Shift Enter to show you, oh my gosh, this is not the place to go to look for help. Yes, you probably could read that and some people might get something out of that. But again, please go over to the Python reference page if you need help. But it is true that you can search for help in the just by doing help and typing the word help, parentheses, and then whatever command you're interested in. I don't have to just sort based on a numeric variable. I can sort based on a text variable, right? What did it do? It just chose the flavors, and you can see that bubblegum starts with a B, so it's at the top. And then again, descending equals true will just reverse the order so that the last thing in the alphabet, like strawberry, will be put first. Okay, and to finish this up, we're going to look at a table called skyscrapers, which is actually pretty interesting because they're all skyscrapers in the United States. And so we know what city they're in, what they're made out of, the name of the skyscraper, how tall they are, and I believe this is in meters. And we know the date completed. Okay, so it's kind of a fun table. And so notice that we're using two methods at once. The first thing we're doing is, hey, I want to sort based on height with the tallest skyscrapers at the top. And then I only want to show 5, which is basically going to show the top 5 tallest skyscrapers in the data table. And we see that the World Trade Center was the tallest skyscraper in this list. Then Willis Tower in Chicago and so forth. You can see on down. The Empire State Building is the 5th tallest at 381 meters. Okay, skyscrapers where city equals Los Angeles. Okay, so this is just going to give me all the skyscrapers. Notice there's one row omitted, so there's another one. This gives me all of the skyscrapers in Los Angeles. Alrighty. And this is going to drop the city, but it's going to find all the skyscrapers where the city is Los Angeles. Okay, so it's basically the same as above, but with the city dropped. Now, what if I just want to look at a building? Hey, I want to see the Empire State Building. Boom. Empire State Building, I just ask where its name is equal to whatever I'm looking for. Okay, skyscrapers where, what is this doing? Where city is New York. See, there's 3 methods here. The dot where is saying, hey, I want the city to be New York. So I only want to look at New York skyscrapers. I want to sort based on the year completed. And then I only want to show 3. Okay, boom. And notice that these are the earliest completed skyscrapers, the 3 earliest completed. What is this one going to do? Well, this one is going to sort in the other direction, so I'll see the most recently completed New York skyscrapers if I do that. Now notice we're doing a where city are contained in. Notice are contained in. What does that mean? It means that if the city name is contained in this text, what text? All of it, the New York City, Los Angeles. So this is going to grab the New York City skyscrapers and the Los Angeles skyscrapers. And it did say show all. So you'll see Los Angeles, a lot of New York City. You're starting to see some Los Angeles, but yeah, all the New York City and all the Los Angeles skyscrapers in there. And we find out, by the way, that there are a lot more skyscrapers in New York City than there are in Los Angeles. Now notice this, where completed, the values in completed are between 1970 and 1980. So remember, show empty parentheses means show all. So we now have a list of all the towers that were completed between 1970 and 1980. And notice that that's inclusive. It includes the endpoints. Okay. This where height are not equal to 300, and then they want to sort based on height and show them all. This is going to be a lot. Let me just go. Well, let's just do it as is. And notice that it has stuff that is shorter than 300. And if you scroll on down, it has things that are higher than 300. Just what it doesn't have is things that are exactly 300. So possibly not the most helpful sort we've done. But if we do want to look at buildings that have heights that are above 300, we can do that. And you can see that the heights here start at 302. So they're starting above 300. And then because we sorted based on height, it starts at the smallest and it goes up to the largest. Now I want you to look at this are contained in New York, Los Angeles, and let's do show. And notice that there aren't any New York City skyscrapers. Why? Well, because it didn't say New York City, it just said New York. So New York City is not contained in New York, Los Angeles. But if I put city in, that's where I'll get all of these results. But what the notebook had was actually New York, Los Angeles. Okay. So hopefully this is going to point out for you. Going to point out what? Well, there are 4 methods we use all the time. And let me go over them. Select, show, sort, and where. Select, sort, show, and where. So you should write that down, and those are, or mark them on the Python reference sheet that you print out or whatever. But you should make a note that select, show, sort, and where are 4 methods that we're going to use all the time. All right, so that's it for this notebook. I hope you have a wonderful day.